Hi there, Joshua here. I had my authority challenged this week. I was teaching this kid algebra, and he said to me, I said to him, straightforward question, I said, what's 3y take away 2y? Yeah, that's fair. I said to him, what's 3y take away 2y? He said, why? I said, because I said so. I'll ask the questions around here. I'm the teacher. I'm in charge. Yeah, I think I put him in his place anyway. So, yep, let's get on with the lesson. Right, so today we're going to be doing solving quadratic equations by the method of factorising. Now, quadratic equation is just an equation with an x squared term. So, for example, x squared plus 2x equals 15. I'm going to be using the letter x in all the examples I do. So it's an equation with an x squared term. It can't have any higher powers than x squared. It can't have x cubed, for example. It can have other terms, though. It can have an x term. It can have a number term. But to be a quadratic equation, it's got to have an x squared term. So here's a quadratic equation. And what we're going to be doing today is we're going to be solving quadratic equations. In other words, we're going to be finding the value of x that makes both sides the same. Now, one way you could try to do this is just try different numbers. So, for example, we could try the number 2, for example. Let's see if that's a solution. Well, 2 squared is 4. 2 times 2 is 4. 4 plus 4 is 8. So, not 15. So, 2 is not a solution. You don't get 15 when you put 2 into the expression. Now, we could try the numbers like this, but it would take a long time. So, you wouldn't want to do that. Normally when you solve equations, you try and rearrange the equation to get x on its own on one side. Now with quadratic equations, that's not so easy, because x is in two different places usually, like it is here. X is in two different places, so it's not easy to get it on its own. You can't combine these terms, for example. So it's a bit difficult to get x on its own. But I'm going to show you this factorising method for solving these sorts of equations. I'm going to show you that now. So the first thing you do is, with this factorising method, is you need to get 0 on one side of the equation. That's the first step. So to get 0 on this side, we could take away 15 from this side, from the right hand side. So we'll take away 15. Of course, what you do to one side of the equation, you have to do to the other side to keep them equal. So we'll take away 15 from both sides. So on the right hand side we do have 0, and on the left hand side we've got x squared plus 2x minus 15. So now that we've got 0 on one side, you factorise the other side. And by factorising the expression, it'll be much easier to spot the solutions. So now I'm going to kind of assume you know how to factorise quadratics already. I did do a couple of lessons on this, so if you're not sure how to do this, you can look for those on my channel. But yeah, let's factorise this expression now. It's a 3-term quadratic, so it goes to a double bracket. To get x squared, we need x and x. We're looking for two numbers with a product of minus 15. I'm just ignoring the minus sign for the moment. Two numbers with a product of 15, so 1 and 15, or 3 and 5. And because they're going to have different signs, we're looking for a pair with a difference of 2. So it's going to be 3 and 5. So 3 and 5. And we want to get plus 2x overall when we expand the brackets, so we need the bigger number to be positive and the smaller number to be negative. So like that. So we've factorised the expression. Now all you need to do to get the solutions is you have to look at each bracket separately and think to yourself, what makes that bracket 0? What value of x makes that bracket 0? So what value of x makes the first bracket 0? In other words, what take away 3 is 0? Well, 3 take away 3 is 0. So 3 is our first solution. If you look at the second bracket, what plus 5 is 0? Well, minus 5 plus 5 is 0. So minus 5 is the second solution. So these are the two solutions. You can see they work because if you put 3 into this expression, 3 take away 3 is 0. 3 plus 5 is 8. So this bracket is 0, this bracket is 8. 0 times 8 is 0. So 0 times anything is 0. So 3 works when you put it in here. When you put minus 5 in, minus 5 take away 3 is minus 8. Minus 5 plus 5 is 0. So this bracket is minus 8, this bracket is 0. minus 8 times 0 is also 0. So as long as you choose an x value that makes one of the brackets 0, you've found a solution basically, because anything times 0 is 0. Right, so what I'm going to do now is I'm going to do lots of different examples, but I'm going to try and keep them quite varied so that each one's a bit different from the last. This first one's actually going to be similar to the one we just did. So x squared plus, let's do 3x equals 18. It's quite similar to the last one, so let's solve that. So first step is you need to get 0 on one side of the equation. So to get 0 on this side, you can just take away 18. You can just do the same to this side, take away 18. So let's write down what we've got left on each side. So on the right hand side we've just got 0, and on the left hand side we've got x squared plus 3x minus 18. So step 1 done, we've got 0 on one side, and then step 2 is to factorise the expression on the other side. So again it's a quadratic with 3 terms, so it will factorise to a double bracket, x and x, and then we're looking for a pair of numbers with a product of minus 18, so again they're going to have different signs. Just ignoring the signs for now. Again, let's just focus on pairs of numbers with a product of 18, so it's 1 and 18, 2 and 9, 3 and 6, and because the signs are different we're looking for a pair with a difference of 3. So it's going to be 3 and 6. So 3 and 6, and yeah, to get plus 3 overall, plus 3x when you expand the brackets, you need the bigger one to be positive again. So it's going to be that way round. So that's the expression factorised. And now to find the solutions, you just look at each bracket in turn and think what makes that bracket 0. So what value of x makes this bracket 0? Well, it's 3. 3 take away 3 is 0, so 3 is a solution. And what value of x makes this bracket 0? Well, it's minus 6. So that's the second solution, minus 6. Now it's a good idea often to check that the solutions work in the original equation. Just to check that you haven't made a mistake. So let's just do that. Let's just check 3 as a solution. 3 squared is 9. 3 times 3 is 9. 9 plus 9 is 18. So 3 works. 3 is a solution. Let's just check minus 6 now. So minus 6 squared, minus 6 times minus 6 is positive. A negative times a negative is positive, so it's 36. 3 times minus 6 is minus 18. 36 minus 18 is 18. So minus 6 also works, that's also a solution. So it's always a good idea to check your answer in the original equation. Right, let's do a couple more on this board here. X squared plus 18 equals 11x. So just like this one, we've still got 3 terms, an x squared term, an x term and a number term. They're in a slightly different order here though. You've got the x term on this side. It doesn't really make a difference. First step, if you're doing the factorising method, is to get 0 on one side of the equation. So we can take away 11x from this side, and of course from this side as well. So what we're left with on each side, we've got 0 on this side, x squared plus 18 minus 11x on this side. Now I'm just going to reorder the terms. When I factorise, I find it easiest to factorise quadratics if you've got the x squared term at the front and the number term at the end. So I'm just going to reorder these two terms, just switch these round. So x squared minus 11x I'll put in the middle, plus 18 I'll put at the end, equals 0. Right, now we've got 0 on one side, so we factorise the expression on the other side. So again, it's a quadratic with 3 terms, so it goes to a double bracket, x and x. And we're looking for a pair of numbers with a product of 18, which means that the signs must be the same this time. They're either both positive or both negative, the two numbers in the brackets. Because we've got minus 11x here, we know they're both going to be negative numbers. So let's put the signs in straight away. You can always put the signs in straight away if the signs are the same. Right, let's focus on pairs of numbers with a product of 18. 1 and 18, 2 and 9, 3 and 6. And because the signs are the same, this time we're looking for a pair with a total of 11. So that's going to be 2 and 9. 2 and 9. Right, so to get the solutions now, you just look at each bracket and think what makes that bracket 0. So what makes this bracket 0? Well, it's 2. 2 take away 2 is 0. What makes this bracket 0? Well, it's 9. 9 take away 9 is 0. So those are the two solutions. Again, let's check them. Let's check and see if they work in the original equation. So let's just check that 2 works. On the left-hand side you get 2 squared, which is 4, plus 18, which is 22. And on the right-hand side you get 11 times 2, which is also 22. So 2 does work. When you put 2 in, both sides equal 22. So it works. Let's put 9 in and see if that works in the equation. 9 squared is 81, plus 18 is 99. So 99 on the left-hand side. On the right-hand side, 11 times 9 is also 99. So 9 is also a solution. Right, let's just do one more example over here. Let's do x squared equals 7x. Now notice this equation has only 2 terms. It doesn't have a number term, but it's still a quadratic equation because it's got an x squared term. So you do exactly the same method. You get 0. First step is to get 0 on one side. So you can take away 7x from this side and from this side as well. And you'll have 0 on the right hand side. Left hand side you've got x squared minus 7x. Notice here we've got a quadratic with only 2 terms. It doesn't have a number term. Now if the quadratic doesn't have a number term, that means it factorises to a single bracket, not a double bracket. So to factorise this, you just look at each term and think, what's the common factor of both terms? So what's the common factor of these terms? Well, it's x, so that goes outside a bracket. It's just a single bracket, remember. And then x times what is x squared? Well, x times x is x squared. X times something is minus 7x. It's minus 7. X times minus 7 is minus 7x. So again, we've got, just like we had here, we had like 2 brackets multiplied together. Here we've got 2 things multiplied together. We've got x and x minus 7 multiplied together. We just need to look at them separately and think what x value makes each of those 0. So what x value makes this bracket 0? Well, it's just 7. 7 take away 7 is 0. So that will work. Because if you put 7 into the expression, you get 7 here, times, and then 0. 7 times 0 is 0. Anything times 0 is 0. And what's the other solution? Well, what makes this 0? Well, because it's on its own, 0 is another solution. Just making that 0 will work in this equation, because if you do that, you'll get 0 here, times 0 take away 7 is minus 7, and 0 times minus 7 is also 0. So if x is on its own like this, then 0 will be one of the solutions. So the 2 solutions are 0 and 7. Right, I'm now going to do 3 slightly harder examples. In the next 3 equations there's going to be a number in front of x squared, which makes it slightly harder, but not that different. So 2x squared plus 7x equals 4. So notice we've got a number in front of x squared now. First step though is same as before, you have to get 0 on one side. So you can take away 4 from both sides. So 2x squared plus 7x minus 4 equals 0. And then you factorise the expression on this side. So because it's a quadratic with 3 terms, it still goes to a double bracket. But this time we need 2x and x at the start of each bracket, because 2x times x is 2x squared. And we're looking for a pair of numbers with different signs, because they need to have a product of minus 4. So the numbers are going to have different signs, but ignoring the signs for now. Pairs of numbers with a product of 4 are just 1 and 4, or 2 and 2. And because the signs are different, normally we'd be looking for a pair with a difference of 7. That's how you get this term here. But because of the 2x here, whichever number we put in this bracket is going to get doubled if you expand the brackets. So we're actually looking for a pair with a difference of 7 when one of the numbers is doubled. So which pair, when you double one of the numbers, has a difference of 7? Well, it's 1 and 4. So if you double 4, you get 8, and 1 and 8 have a difference of 7. So the 4 needs to go here, and the 1 here. Now we've got to decide which one's positive, which one's negative. At the moment, without signs, we've got 1x here, and 8x here. 2x times 4 is 8x. And we want them to add up to positive 7x. And that means the bigger one has to be positive, and the smaller one has to be negative. So it needs to be that way round. So we need minus 1 and plus 4. So that's how it factorises. Right now we can work out the solutions just by looking at each bracket separately. So we'll start with this bracket. What makes this bracket 0? Well, it's minus 4. Minus 4 plus 4 is 0. And which value of x makes this bracket 0? Well, it's not so obvious because of the 2 in front of x. That makes it a bit more difficult. The answer isn't 1, by the way. If you put 1 into this expression, 2 times 1 is 2, take away 1 is 1, not 0. Remember, we're looking for the x value that makes this bracket 0. So in this sort of situation, when you've got a number in front of x, it is a bit harder. And what you can do is you can just solve an equation at the side. So we want 2x minus 1 to equal 0. If we solve this equation, then we'll find which value of x makes this expression 0. So to solve this equation, we just need to get x on its own. You can, to get rid of the minus 1, you can just add 1 to both sides. So you get 2x equals 1. And to get rid of the 2, you can just divide both sides by 2, and you get x equals a half. So that's the value that makes this expression 0. You can try it and check that it works. 2 times a half is 1. Take away 1 is 0. So the two solutions are x equals minus 4 and x equals a half. Let's do just a couple more over here. So 3x squared plus 19x plus 20 equals 0. So notice we've got 0 on one side, so we don't need to do any rearranging here. We can go straight to the factorising stage. So it factorises to a double bracket. It'll be 3x and x at the start of each bracket this time, because 3x times x is 3x squared. Everything's positive on this side, so the two numbers in the brackets are both going to be positive numbers. And we're looking for a pair of numbers with a product of 20. So we'll list all the possible pairs. It's either 1 and 20, or 2 and 10, or 4 and 5. And because the signs are the same, normally we'd be looking for a pair with a total of 19. But because of the 3x here, whichever number we put in this bracket would get tripled if you were to expand the brackets. So we're actually looking for a pair with a total of 19 when one of the numbers is tripled. So which pair, when you triple one of the numbers, has a total of 19? Well, it's 4 and 5. Because if you triple 5, you get 15, and then 4 plus 15 is 19. So the 5 needs to go here, so that it would get tripled if you were to expand the brackets, and the 4 here. So that's how it factorises, and now we can work out the solutions just looking at each bracket separately. So which value of x makes this bracket 0? Well, it's minus 5. And which value of x makes this bracket 0? Again, it's a bit harder because of the 3 in front of the x. So whenever you have a number in front of x, you can always sort of solve an equation at the side. You can just set this equal to 0. We want 3x plus 4 to equal 0. By solving the equation, we'll find the x value that makes this 0. So you want to get x on its own. To get rid of the 4, you can just take away 4 from both sides. So you get 3x equals minus 4. And now to get x on its own, you just divide both sides by 3. So you get x equals minus 4 over 3, minus 4/3. So that's the second solution. So the two solutions are x equals minus 5 and x equals minus 4/3. Right, let's do one more over here. So 2x squared plus 5x equals 0. Again, notice we've got 0 on one side, so we can straight away factorise this expression. We don't need to do any rearranging. Also, this expression only has two terms. It doesn't have a number term. Now, when a quadratic doesn't have a number term, then it factorises to a single bracket, not a double bracket. So what goes outside the bracket? Oh, well, we've got to think what's common to both terms, what's the common factor, and that's x. X is the common factor. So what goes inside the bracket? Well, x times 2x is 2x squared, and x times 5 is 5x. So that's how it factorises. So we've still got something times something equals 0. It's x times 2x plus 5 equals 0. So again, we've got to think what makes each of these things 0. If you remember from an earlier example, if x is on its own, then 0 is a solution. So x equals 0 is a solution. And the other solution we'll get by thinking what makes this bracket 0. Again, it's a bit harder because you've got a 2 in front of x. So as I said, whenever you've got a number in front of x, it's a bit harder, and you can always solve an equation at the side. You can just set it equal to 0, because we want 2x plus 5 to equal 0. And if we solve this equation, we'll find the x value that makes this 0. So to get x on its own, first step, you can just take away 5 from both sides. So you get 2x equals minus 5. And then the next step is just divide both sides by 2. And you get x equals minus 5 over 2. That's the same as minus 2.5, but you can leave it as a top-heavy fraction like that. So the two solutions are x equals 0 and x equals minus 5 over 2. Right, I'm just going to finish off with two more examples. In these next two examples, there's going to be a negative number or a negative sign in front of x squared. So here's the first one. 6 plus x minus x squared equals 0. So notice there's a negative sign in front of x squared. Now, because we've got 0 on one side, we can go straight ahead and factorise the expression on this side. But I find it difficult to factorise a quadratic if there's a negative sign in front of x squared. I find it much easier to factorise if there's a positive number or a positive sign in front of x squared. So what can we do to get rid of this negative sign in front of x squared? Well, you can add x squared to both sides of the equation. If you add x squared to this side, it'll get rid of the minus x squared. And if you add x squared to this side, there'll be a positive x squared on the right-hand side. So let's just write down what we've got left on each side. So on this side, you've got 6 plus x, because the x squared sort of cancels out the minus x squared. And on this side, 0 plus x squared is just x squared. And actually, I'm going to get rid of all the terms from this side. I'm just going to end up with 0 on the left-hand side and all the terms on the right-hand side. So to get rid of x, I'm just going to take away x from both sides. So what we're left with 6 on the left-hand side and x squared minus x on the right-hand side. And now to get 0 on the left-hand side, just take away 6 from both sides. So now we've got 0 on this side, and x squared minus x minus 6. So notice we've now got x squared instead of minus x squared. So this should be much easier to factorise. So let's do it. Let's factorise the expression. It goes to a double bracket, x and x, and we're looking for a pair of numbers with different signs because they need to have a product of minus 6. But ignoring the signs for now, pairs of numbers with a product of 6 are just 1 and 6 or 2 and 3. And because the signs are different, we're looking for a pair with a difference of 1. Because we've got minus 1x here, I could put a 1 there. So which pair has a difference of 1? Well, it's 2 and 3. So 2 and 3. And because we want minus 1x overall, the bigger number needs to be negative and the smaller one positive. So it needs to be minus 3 and plus 2. That's how it factorises. Let's write down what the solutions are now. So what value of x makes this bracket 0? Well, it's minus 2. And what value of x makes that bracket 0? It's 3. The two solutions are x equals minus 2 and x equals 3. Right, let's just do one more example to finish off. This is the last example. 11x minus 2x squared equals 15. So again, we've got a negative number in front of x squared. So again, to deal with that, what you can do is you can add 2x squared to both sides. So if you add 2x squared to this side, it'll get rid of the minus 2x squared. And if you add 2x squared to this side, you'll have positive 2x squared on the right-hand side, which will be easier to work with. So let's just write down what we've got left. We've got 11x on this side, 15 plus 2x squared on this side. Right, so to get 0 on this side now, just take away 11x from both sides. Take away 11x, take away 11x. So you've got 0 on the left-hand side, and 15 plus 2x squared minus 11x. So notice we've got 2x squared rather than minus 2x squared, so this should be much easier to factorise now. Before we factorise, I'm just going to reorder the terms. I find it easiest to factorise if there's a positive, if the x squared term is first, and if the number term is last. That's just the familiar order to me. So I'm just going to reorder the terms. So 2x squared at the front, minus 11x in the middle, and I'll put the number at the end, plus 15 at the end. So let's factorise it now. So it goes to a double bracket, We need 2x and x in the brackets. 2x times x is 2x squared. The numbers in the brackets are going to have the same signs because they need to have a product of positive 15. But because we've got minus 11x here, that tells us that both numbers must be negative. So because we know they're both negative, I'll just put the signs in straight away. And pairs of numbers with a product of 15 are 1 and 15, or 3 and 5. And because the signs are the same, normally we'd be looking for a pair with a total of 11. But because of the 2x here, whichever number we put in this bracket would get doubled if you were to expand the brackets. So we're actually looking for a pair with a total of 11 when one of the numbers is doubled. So which pair, when you double one of the numbers, has a total of 11? Well, it's 3 and 5. So if you double 3, you get 6, and 6 plus 5 is 11. So the 3 would need to go here, so that it would get doubled if you were to expand the brackets, and the 5 here. So that's how it factorises. Let's work out the solutions now. So just looking at the end bracket, what value of x makes that bracket 0? Well, it's 3. 3 take away 3 is 0. And what value of x makes this bracket 0? Well, it's not so obvious because of the 2 in front of x. Whenever there's a number in front of x, it makes it a bit harder. And what you can do is just solve an equation at the side. So we want 2x minus 5 to equal 0. If we solve this equation, we'll find the x value that makes that 0. So to get rid of the minus 5, you can just add 5 to both sides. And you're left with 2x equals 5. And then to get rid of the 2, you just divide both sides by 2. And you get x equals 5 over 2. So the two solutions are x equals 3 and x equals 5 over 2. Right, that's the end of the lesson. Now there is something I didn't mention about this factorising method, and that is that a lot of the time it just doesn't work. Yeah, so for this equation here, for example, if you try and solve it using the factorising method, it won't work, because although we've got 0 on one side of the equation, this expression just doesn't factorise. There aren't two whole numbers with a product of 6 and a difference of 2. And this equation has solutions. It has two solutions. It's just you're not going to find them using the factorising method because this expression doesn't factorise. But next lesson I'm actually going to show you a completely different method for solving quadratic equations called completing the square. And you can use that method whenever the factorising method doesn't work. So that's going to be next lesson. But for now, I'm going to put some questions at the end of this video for anyone who wants to practice what we did today. And you can have a go at solving some quadratic equations using the factorising method. I'm also going to put the answers after that, so you can pause the video, have a go at the questions, and then look at the answers in that order. Right, here are the questions. Bye.